And so the value of money is therefore dependent on the time at which it was received. So that's why we're talking about the issue of discounted cash flow techniques, and we'll be looking at some of them and maybe try to rehearse how to calculate with them. So a sum of money on hand today is worth more than the same sum of money to be received in the future, because the money on hand today can be invested to earn interest or to gain more than the same money in the future. And so studying the present value of money, or the discounted value, then that will be received in the future, therefore it becomes very, very important. So the first thing is simply the present value. It describes the process of determining what a cash flow to be received in the future is worth in today's value. So some money that you expect to receive in the future, you actually tabulate what is the value of that money in today's present value. Therefore, the present value of a future cash flow represents the amount of money today, which, if invested at a particular interest rate, will actually grow to the amount of the future cash flow at that time in the future. Now, the other thing is the process of finding present values is actually called discounting, and the interest rate that is used to calculate the present values is known as the discount rate. I'm going to show you a formula that is very, very applicable in terms of using that to be able to do discounting. So now, if you look at this example, if you are to consider to invest 100 today, with an interest rate of 10% compounded annually, then this investment will actually grow to 110, and that is 100 multiplied by 1.1 in 1 year, and the investment that is earned is actually 10. Now in year 2, if the current balance, that is Kenya shillings 110, will be invested, and this investment will actually grow into 121 because if you consider 110 multiplied by 1 plus 0.1, we will actually be able to see that is why we are getting 121. And so accordingly, investing a current amount of money. So using those two examples I've given now, we can actually be able now to come up with a formula, and this is what I'm arriving at now, that investing a current amount of money P for 1 year with the interest rate R will result in a future amount C. And so using the following equation, we can be able to make the following statement, that C therefore equals to P dot, means we multiply by 1 plus R raised to the year in which we are calculating that particular discounted value. If P therefore is invested for n years, then the future amount C will be calculated as per the equation 2 below. C therefore will be equal to P multiplied by 1 plus the rate and raised to power n. And so contrary to the equation 2, the present value, that is the discounted value, P, over future sum of money C that will be received after n years when the discount rate is R, will be calculated as per equation 3 below. So there we just reverse the letters. Initially in the previous equation, we were trying to calculate and look for C. Now we want to look for P. And so this is easy. So if you want to look for P, then it's C, and then you divide with 1 plus R raised to power n. And so, for example, the present value of Kenya shillings 100,000 to be received 3 years from now is simply 75,130 if the discount rate is compounded annually. So if you replace 100 there, then you divide by 1 plus 0.1, then raise it to power 3. If you do that, you're likely to be able to get 75,130. And so if we take this example 1 and you're asked to calculate the present value of the following cash flow streams, given that the interest rate is 100. So there we were only calculating for 1 year, but now if you're asked to calculate for each of these years, then what would you actually be able to get? So you can note this formula down. So note it somewhere that P, the present value, equals to the future value divided by 1 plus the rate raised to power n. So once you've noted it, then I want us to be able to use that formula to calculate the value for year 1. Remember, the value for year 1 will be, you will say 100. So C there is 100,000. Then you will divide it with 1 plus 0.1 raised to power 1, because that is for year 1. For year 2, I would expect you to say is 200,000 divided by 1 plus 0.1 raised to power 2 now, because this is the second year. And then year 3, I would expect you to be able to put 200,000 as the C value, and then divide this with 1 plus 0.1 raised to power 3. And then for year 4, then I would expect you to put 300,000 divided by 1 plus 0.1 raised to power 4. For year 1 was coming to 90,910, because we are saying as much as we are expecting the project to be able to give these cash flows, but in today's present value, then those values will actually be as follows: 90,910, 165,220 for second year, for third year, and for fourth year, 150, 260, or 204,900 respectively. So if you total up that, then it gives you a total of 611, 370. Let's now look at another technique, and this is what we call the net present value. So it still uses the same concept, but normally in net present value, we also consider the cost of investment, which will normally be the negative value, because this is the money that we poured into the project, and so we are able to sum up everything as per the net present value. So in net present value, what you do is simply the summation of all present values of cash flows of the project, where the expenses are considered negative and the incomes are considered positive. And so that's the only thing that we didn't do in the past example of the present value, because we didn't have any consideration for a negative value. And so that's why we were able to work with only the positive values as expected. But ideally in a normal situation, then you will actually be able to work with both negative values and positive values. So a project is considered profitable if it will actually have a positive net present value. So once you do summation of your present values, then if a project contains positive value, then it is considered worth investing. However, if you are comparing between two projects, then the one with the largest positive net present value, or NPV, will actually be selected respectively. We have another example here now. So what you will do for project A, you will actually consider the C to be negative 100 divided by 1 plus 0.1 raised to power 0, because that's year 0. For year 1, you will have 500 divided by 1 plus 0.1 raised to power 1. For project A, year 2, you will also say C will be 400 multiplied by 1 plus 0.1, and then now you're able to get that. So the same way we were applying the formula in the other example as well. So once you get all your values for project A, you total them up, because totaling them up is what gives you the net present value. Then for project B, once you calculate the present values for year 0 all the way up to year 5, then you total them up. I think you can just do a spot check for what you managed to calculate, because what I wanted to make sure you can get used to is the use of the formula. So what you can see is that once you are able to calculate for A, you will actually get, once you total them together, you will actually be able to get 134.08, and once you calculate for B, you're going to get 114.31. Now, if these are two projects and you needed to select them using a capital budgeting technique, then of course you would actually select project A instead of B, because project A has a higher net present value. So A actually becomes something that we need to select because it has a higher net present value. So that's basically what the net present value. Let's look at another technique as well, because we have quite a number of techniques that we can use. We've looked at the present value, the net present value,